Welcome back, students. We are back with another lesson. In this lesson, we will discuss analytical method of vector addition. Now, you are given two vectors, your vector A and your vector B. Your vector A is represented by OP, represented by PQ. Fine. Now, from the triangle law of vector addition, we know we can draw a resultant vector R, and this R will be the vector sum of vector A and your vector B. Now, draw Qn perpendicular to OP in such a manner. Now, we will find the expression for the magnitude of R, or your resultant vector. To find out the magnitude, let us consider your triangle QPN. Find this red triangle. Now, in this red triangle, your angle QPN equals to theta. Your OP represents your vector, so OP will represent the magnitude of the vector A. The magnitude or the numerical value of the vector A is A. Now, PQ represents your vector B. So the magnitude of the vector B will be B. So PQ will be the magnitude of the vector B. Similarly, OQ is the magnitude of the vector R. So I have written R. Now, in this triangle, consider these two sides, your side PQ and your side Q1. Now, using our trigonometric property, we can write Qn by PQ equals to sine theta. Opposite side Qn divided by your hypotenuse gives us sine theta. So, if I want to write Qn, I can write Qn as PQ sine theta. I can send this PQ to the other side. Fine. Now we know PQ is the magnitude of the vector B. So I can also write this one as B sine theta. Now in similar manner, again consider the triangle QPN. Now this time consider these two sides, your side PQ and your side PN. Now your cos theta is the ratio of the adjacent side PN divided by your hypotenuse PQ. Fine. Again, I can write my Pn as PQ cos theta. I can send this PQ to the other side. So Pn equals to PQ cos theta. Now PQ represents the magnitude of your vector B. So I can also write B cos theta. Now consider your triangle OQN. This is a right angle triangle. So if this is a right angle triangle, according to hypotenuse theorem, OQ square, or I will say according to Pythagoras theorem, OQ square equals to ON square. Your hypotenuse OQ square equals to ON square, your base square plus your height square, QN square. Now your first part can be OP and your second part can be your PN. So ON I can write as OP plus PN whole thing square plus QN square. Now we know OP is magnitude of the vector A, so I'll write simply A. Now Pn, as we have derived, it is B cos theta. So A plus B cos theta whole thing square. And Qn as we have derived is B sin theta. So B sin theta whole thing square. And OQ, this OQ represents your resultant vector R. So OQ is the magnitude of R. So R square equals to A plus B cos theta whole thing square plus B sin theta whole square. Now we'll open up the bracket. So I can write, if I open this one, I can write A square plus B square cos square theta plus twice of AB cos theta, and this one B square sin square theta. Here B square and B square are two term common, then I can write A square plus B square common cos square theta plus sin square theta remaining plus twice of AB cos theta. What is cos square theta plus sin square theta? This one equals to 1. Therefore, here the only thing will be left is B square. So I can write A square plus B square twice of AB cos theta. So my R square equals to A square plus B square plus twice of AB cos theta. Now if I want to find out the magnitude of R only, then what I will do? I will take the square root of this value. So R equals to square root of A square plus B square plus twice of AB cos theta. So the magnitude of this R is root over A square plus B square plus twice of AB cos theta. Fine. Now moving on to direction of our resultant vector. Now let R be the resultant vector. This R makes angle beta with the direction of the A vector. Now consider your triangle ONQ. Again, your triangle ONQ is a right angle triangle, so we can use trigonometric property. So tan beta equals to the ratio of the opposite side QN divided by your adjacent side ON. Fine. Now your ON can again split into two parts, OP plus PN. So tan beta equals to QN divided by OP plus PN. Now we know QN is B cos B sin theta, so I've written B sin theta, and OP is the A, and PN equals to B cos theta, so I've written B cos theta. So the direction of the resultant vector, or I can say the tangent of the angle beta, equals to B sin theta divided by A plus B cos theta. Fine. This same principle can be applied to your parallelogram law. If you are given a vector A and you are given another vector B, and there is an angle theta. Now if we draw a resultant according to the parallelogram law, which we have discussed in our previous class, in this case this resultant vector will be sum of the vector A and your vector B, and the magnitude of this resultant vector will be A square plus B square plus twice of AB cos theta, and the direction of this resultant vector will be tan beta equals to B sin theta divided by A plus B cos theta. Fine. Now moving topic, resolution of vectors. So what is a resolution of a vector? It is the process of splitting a vector into two or more vectors in such a way that their combined effect is same as that of a given vector. The vectors into which a given vector is splitted are called the component vectors. Now the resolution of vector means how to split a resultant vector into its two components. Now we have studied our In that case, what we have studied, we had a vector A, we had another vector B, and the resultant, the sum of these two vectors is this vector. This is the resultant vector. Now, the resolution of a vector means, suppose you are given this vector. So, the resolution of this vector means we will split this vector into its component vector, into your vector A and into your vector B. Fine. So here we have learned that your vector A plus your vector B gives your resultant vector R. So we have added this two to get our resultant vector R. But in case of resolution vectors, what we will do, I will split my resultant into the two components vector A bar and B bar. So my resultant vector R vector equals to A vector plus B vector. So this is just the opposite case of your vector addition. Fine. So let's see your resolution of vectors. Now you are given two vectors, your vector A and this is your vector B. Fine. Now there is a third vector OQ or your R vector. Fine. So we have to resolve this R vector along A vector and along B vector. So how will we do it? First, let's draw a line which is parallel to your A vector. Fine. So I've drawn this dotted line. Now this dotted line represents your A vector, but not exactly equal to your A vector. It might be some multiple of your A vector. So I've written lambda A bar. Fine. So OP, this is OP, okay. So OP is parallel to your A vector. Therefore, I can write OP as some multiple lambda times A vector. Fine. Now, in similar manner, let us draw a line parallel to your B vector. Now, again, this parallel line is parallel to your B vector. So it represents B vector, or I can say it is some multiple of a B vector where mu is some any random value. So since PQ is parallel to your B vector, therefore PQ equals to mu B. Fine. Therefore, what I can do is I can write my resultant vector in terms of this vector lambda A bar and in terms of this vector mu B bar. Therefore, I can, according to my triangle law, your R vector is the vector sum of lambda A bar and mu B bar. Fine. So this is the resolution of vectors. Splitting of this resultant vector R into its corresponding component vector, your lambda A bar and your mu bar. Fine. So moving on to our next topic, unit vectors. Fine. I'm pretty sure you must be familiar with this term. Your unitary method. Fine. Now what happens in a unitary method? Let's take an example. Suppose you bought 10 pens and the price of this 10 pen, let us say it is 100 rupees. So what will be the price of one pen? So price of one pen equals to 10 rupees. Fine. So in this method, what we have done, we know the price of 10 units, and using this 10 units we have found the price or the value of 1 unit. Fine. Let us say we have a vector. Okay, this is your vector, let us say 5, or let us say 3 a bar. Fine. Now what we will do is, let us 3 components, your one component, second component, and your third component. So let us assume a vector, this one. Fine. So let us consider this vector. This vector is also in the direction of your 3a vector. And how much will be this component? This component will be 1 unit. So it will be simply a vector. Fine. So this will be your unit vector. So how can I define a unit vector? A vector which is along the direction of your principal vector, your 3a direction, this yellow line, and it has a magnitude of how much? 1. Such vectors are known as your unit vectors. And note, we will denote your unit vectors by this symbol a cap. So to write a unit vector, you write vector a and you denote a cap. Fine. So this is also like your unitary method. Earlier you had a vector, 3 units of a vector, and you found out the value of 1 unit of a vector, which is your unit vector. Fine. Now why this unit vectors are important? Because using this unit vector we can find any amount of the vector along this direction. Fine. So if I want to say what will be the value of a 5 vector, so we know a vector, this is moving in this direction. Fine. So what I will do, 1 unit vector, again 1 more unit vector, 1 more unit vector, 3 units, 4 units, 5 units. So this will give us another vector 5a bar, which is along the direction of 3a bar. Fine. And how did we find out? Using the help of our unit vector. Fine. Now in the similar manner, so we can find the unit vector along the 3. So suppose this is my x coordinate axis. So the unit vector along the x coordinate axis is I cap. The unit vector along the y coordinate axis is j cap, and the unit vector along the z axis is k cap. Fine. So we will use throughout to represent the unit vector along the x axis, along the y axis, and z axis. Fine. Now moving on to another topic, rectangular components of a unit vector. Now the rectangular components of unit vector. Now suppose you are given a vector A. To find out what will be the resolution of this vector A, the resolution of the vector A will be ax vector plus ay vector. Ax vector is along the x-axis, ay vector is along the y-axis. Fine. Now this ax vector I can also write as ax equals to ax. Ax means the magnitude of this part. So ax is the numerical value of this part times the unit vector I cap. Fine. Similarly, AY vector I can write AY, the magnitude of this part, AY times the unit vector along y-axis, j cap. So AY vector equals to AY times j cap. Therefore, I can write my A or my resultant vector as AX I cap AY j cap. Fine. AX I cap AY j cap. Now, we can also write this as along. To write this one according to your trigonometric properties, let us consider your triangle OMP. Fine. Now in this triangle, let us consider this angle theta. Now what will be your cos theta? Cos theta is the ratio of the adjacent side OM divided by your hypotenuse OP. OM by OP. Now OM equals to, this is the magnitude part, and how much is this represents your, this one represents your AX vector. And what is the magnitude part of this AX vector? It is AX. Therefore, I can write OM as AX. So OM equals to AX. Similarly, your OP. This is your OP. I can write the magnitude of A vector will be simply A. Fine. So I will write OP equals to A. Fine. So my AX equals to, sending this AX to the other side, I can write AX equals to A. Fine. Therefore, instead of writing AX I cap, I can write A cos theta I cap. Okay. Now on similar note, what will be your sine theta equals to the ratio of the opposite side PM divided by your hypotenuse OP. PM divided by OP. Now note this height PM. Now this height PM is equal to your height ON. So instead of PM I can write ON. So ON by OP. Now this is the magnitude of the AY vector, and the magnitude of the AY vector is AY. Therefore, instead of ON I can write AY. Similarly, for OP I can write the magnitude of vector A. Fine. So what will be your AY? Magnitude AY will be, send this A here. So I have AY equals to A sine theta. Fine. So I can, instead of writing AY j cap, I can simply write A sine theta j cap. Okay. So we know our vector A bar equals to AX bar plus AY bar. Now we have shown our AX bar or your AX vector can be written as A cos theta I cap, and AY, this one, can be written as A sine theta j cap. Therefore, my vector A can be written as A cos theta I cap plus A sine theta j cap. Fine. Now, what will be the magnitude of the A? The magnitude of the A will be, I can simply write A, or I can also write this one as mod of A, which will be equals to AX square plus AY square. Fine. Now, in 3 dimensions, suppose this is your 3 dimension, your x-axis, your y-axis, your z-axis. Fine. This is your resultant vector A. Now your resultant vector A is making alpha with your x-axis or your AX vector. Your resultant vector A is making beta with your y-axis or AY vector, and your resultant vector A is making angle gamma with your AZ vector. Fine. So I can write my, it is shown by this green vector. Can you see this green arrow? I can write this as AX I cap. Similarly, my AY vector, I can write it as AY j cap. My AZ vector I can write as AZ k cap. Fine. So what will be your resultant vector? So the resultant vector A will be the sum of AX plus AY plus AZ, which can also be written as A vector equals to AX I cap plus AY j cap plus AZ k cap. Fine. So what will be the magnitude of A vector? The magnitude of A vector will be your vector A. Okay, you write this one as A. Your magnitude of A vector will be simply A, which will be square root of AX square plus AY square plus AZ square. Fine. So that's it for today's class. Thank you. And if you have any confusion, please feel free to ask. I will re-explain it to you again.